In number 1, they're asking us to rewrite this equation in its equivalent exponential form. So that means we need to recall exactly how that goes. So if I have some log to a base on x, that's going to give me the exponent. So what that means in terms of an exponential function, b is going to be my base. So the same base on the log is the same base on the exponential equation. Doing the log gives the exponent, so my exponent's y equals x. So comparing this to our log equation, we know our base is going to be 6, our exponent's going to be -8, and that is going to be equal to n. In number 2, they want us to rewrite the expression as a single logarithm. I noticed a couple of things here. We have some numbers in front of the logs. Those can be written as the exponents on the argument, so I know I'm going to have a log base 7 u cubed. And then over here, same thing. We have this 3 that can go as the exponent on the argument v. Also notice that we have subtraction. When we have subtraction, that means we can rewrite the negative log as division. So that part is going to go into the denominator. So as a single log, we have log base 7. In the numerator, we have the positive log, so that would be u cubed over, and then our negative log is the v, and that one is also cubed. On a multiple choice question, they might present the answer as this, or since they're both with the same exponent, you might see the answer expressed as log of u over v to the power 3. So that's just a property of exponents, but you might see it that way also. Now in number 3, they want us to solve that exponential equation. The first thing that you want to do when you're solving an exponential equation is to make sure that the base is isolated before we go trying to take the log of both sides. So I want to get rid of that -7 that's multiplying my base of 10. So I'm going to do the inverse operation, which would be to divide by -7. And that would give us base 10 to the x minus 6. And then since we're not going to get a nice number when we divide 47 by 7, I'm just going to leave it like that. 47 over 7. Negative divided by negative is a positive, so I'm going to drop those negative signs. Now I want to express this exponential equation where I have x not in the exponent. So the trick there would be to move to log form, or take the natural log of both sides. So taking the natural log of the left side and the right hand side, and then that means that we would get to use our properties of exponents. So I could move that entire exponent down. I'm going to put parentheses around it because that whole thing is multiplying my natural log of 10, and that's equal to the natural log of 47 over 7, which we can put in the calculator here in a minute. Now I'm also trying to isolate the x. So I see that we're subtracting 6 from the x, but we're also multiplying that whole little binomial by the natural log of 10. So I'm going to divide out the natural log of 10 on both sides. That's going to cancel so that we get x minus 6 equals natural log of 47 over 7 divided by, oops, I dropped my 10 there apparently, divided by the natural log of 10. And I'm going to put that into the calculator and write down what I get. I get x minus 6 equals 0.827. And then the final step in isolating x is to add 6 to both sides. And that gets us x equals 6.827. And of course, we would want to plug this back in for x in order to check our equation, which I've already done. Now number 4, they said the exponential growth model, and then they give us an equation here. It describes the population of a city in the United States in thousands. So P is our population in thousands. T years after 1994. Use this model to find the population of the city in 2015. Okay, so we're going to be using the equation. Our y is our population, and since t is the year since or after 1994, we're going to want to do a little subtraction problem in order to find out what t we need to plug in. So do 2015 minus 1994. That gives us 21. So that means we need to substitute 21 for t into this equation. So in my calculator, I'm going to type 30, base e, remember that's just a number, raised to the 0.019802 times 21. And plugging it in the calculator, we get 45.469. Since this problem mentions that that's the population in thousands, then I want to sort of reframe my answer to be 45,469, and since the population, that would be people.